Hello and welcome back to the CCNA journey with me, Ryan. And in this section, we're going to continue with network access, focusing on the topic of VLANs. In this video, we're going to look at the access and trunks, the difference between them, and we're going to jump and look at the configuration. For those who don't know what a VLAN is, check out my previous video where we go over all the actual theory behind VLANs, why they're needed. And for those who don't know, you can contact me here on YouTube. You can connect with LinkedIn, follow on Twitter, or message me on Facebook. So first of all, we need to know our VLAN range. We have any VLAN from 1 to 4094, and there are subcategories inside this range. There is a standard VLAN range, which spans from VLAN 1 up to VLAN 1005, an extended VLAN range, which is 1006 to 4094, and the VLANs from 1002 to 1005 are called legacy VLANs. So first off, we got this standard VLAN range. These were obviously created way before the use of extended VLANs, and then extended VLANs were added later. But the reason it's important to know that there are two different categories between standard and extended is because later in your studies you're soon to realize that certain protocols, like for example the VLAN trunking protocol, behaves differently depending on whether you're a standard or extended VLAN. But for now, one thing to keep in mind at the CCN and CCNA level is the numbers that are in question here. We need to ensure that we know what range is for standard, which range is extended, how many VLANs are inside the entire range, and why the VLAN 1002 and 1005 are what's called legacy VLANs. These are for older technologies like FIDI and token ring. These are outside the scope of the current certifications, including the CCNP and CCIE, but they're there left over, and you can actually see them inside the Cisco. Lastly, this is concept of VLAN 1. I've put a comment here that says everything is in VLAN 1 even right now. What I mean by that is when you first purchase the switch, and that may be a Cisco switch and it may be another switch that supports the VLAN feature set, but ultimately what you're left with is normally by default every single port on that switch is a member of VLAN 1. That's the default, sometimes referred to as native VLAN on this switch. Even if you don't enable VLANs, they still have, or the ports are still part of VLAN 1. So this means that by default, if we were to plug a couple of PCs, put them onto the same /24 subnet, we would have reachability between the two devices because again, they're inside the same VLAN. And we can see that by looking at the Cisco itself. Okay, so here we are just on a switch. Now in order to create the VLAN, we'll go into the config terminal, and from the config terminal, we're going to type the word VLAN, ? And you can see that the top entry here specifies how many VLANs that we can actually create, and is asking us to pick a VLAN ID, which is what we're going to do here. As for the other options, these are outside the scope for this video, and most of which are outside the scope for the CCN or CCNA. So from here, what we're going to do is simply type a number, let's say VLAN 14, and it'll take us into the subcommand of that VLAN. From here, if we press ? we have a variety of different options, but the option that we're really interested in here is to actually give the VLAN a name. Let's give it the name test. When we come out and actually end, it will then create that VLAN for us. So that VLAN is now being created. If we hit show VLAN, it come up with the output of the VLANs that are currently on this Cisco switch. We can see here the VLANs. You'll notice that VLAN 1, which I said is the default VLAN. We can see VLAN 14, which is our test VLAN that we've previously named, and one that I've created, VLAN 169, but I didn't name it, hence why
it's got this VLAN 0169 in the name. Now, we also can see the status of the VLAN. The status here shows it's active. The other statuses it could be is something like suspended or shut down, but you can see that it's actually currently active. And we can also see if there are any ports that have been assigned to that VLAN. Now, as previously explained, that VLAN 1 is where all of our ports currently live by default. So when you come along and you turn on this switch, gig 1, gig 2, 3, all the way up to, in this case, 48, and the 2 uplink 10 gig ports all sit inside the same broadcast domain, and they can all communicate with one another by default. Now, we did create our VLAN 14, but all of our ports remain inside VLAN 1. That means that at the moment VLAN 14 is not being utilized, and we'll need to actually move this port into VLAN 14 in order to put it into its own VLAN and in turn its own broadcast domain. Okay, so touch base on what we've just gone over. We just created a VLAN and then we verified that VLAN. Now there's two ways to create a VLAN. We can do that globally, which is what we just done. We went into the config terminal, we typed the word VLAN, and then we put the VLAN after it, just like it's shown here, where we can create VLAN 100. Or we can do it at time of assignment. Now, a time of assignment relies on things like, again, VTP, the VLAN trunking protocol. That's something that we've not covered yet, but for those who are a bit ahead of their studies, in order for time of assignment to work, you need to make sure that you're either in server mode or transparent mode. Ultimately, you need to make sure that the switch you're on has the permission to create VLANs. Now, what do I mean by at time of assignment? Well, previously I said that we've created a VLAN, but we didn't assign any ports to it, and all of our ports remained in VLAN 1. Well, what you can do is you can actually go onto an interface and make the interface part of a VLAN that may not actually exist. So for example, I might go under gig 05 and make it part of VLAN 100. But because VLAN 100 doesn't actually exist on the switch is actually clever enough to create that for me. So to give you an example of that, here I am back on that switch. We can see that so far I have VLAN 1, 14 and 169. I do not have VLAN 10. If I navigate to a port and put it inside VLAN 10, let's see what happens. Straight away you'll see what the CLI comes back with. It says this VLAN does not exist, so I'll create it for you. If we now do the verification command like we did previously, show VLAN, we have VLAN 10 created and gig 02 has been assigned. Notice that gig 02 is no longer part of VLAN 1. It goes port 1, port 3, port 4. There's no port 2 because port 2 is part of VLAN 10. We also have the power to name the VLAN, suspend the VLAN, shut down the VLAN, and change the media type. So media will always be Ethernet, because that's what we're using our VLANs for. We have a name. You can name the VLAN rather than just leaving it its default number, because we sometimes like to put names against numbers, because obviously people relate to names easier. And if you're controlling hundreds of VLANs a day, maybe for each different department, it's nice to know which VLAN is what department rather than having some sort of lookup sheet. And then we can also have the option to suspend and shut down a VLAN. The difference between suspending and shutting down is if we were to shut down the VLAN, that's a local action, meaning it only affects the switch you're currently on. If you were to suspend the VLAN, this would be propagated out towards everyone inside the VTP domain. Something very important here is until you exit out the VLAN configuration mode, the VLAN does not get applied to the device. And in order to verify your work, we can use show VLAN, which was previously demonstrated. Show VLAN brief, which is a brief output but shows nearly the same information. And show VLAN dash switch. And this is for built-in switches. What do I mean by that? Well, some routers, for example, the ISR series, the integrated services routers, like the 2900s or the older 2600s and so forth, you'll notice that they've got an actual expansion bay. Well, inside that expansion bay, you can actually get a very basic 4 or 8 port switch, and that could accommodate a LAN or actually give you different options in order to terminate networks. As far as the exam is concerned, you need to definitely know how to create the VLANs both globally and at time of assignment. You need to know that VLANs have a large range of anything from 1 to 4094 and the different categories and why they exist. Why they exist we'll get into in later videos. You need to know that VLANs can have a name and how to verify it. Okay, so far we've talked about why we need VLANs and the fact that they break up broadcast domains, and in turn normally you put a single subnet inside a single VLAN. We've seen how VLANs are created and the ranges of VLANs, and we also seen the verification steps in actually verifying what VLANs we have and what ports live inside which VLANs. We're going to take that one step further now, and we're going to address this thing called access ports and trunk ports, and the differences between them and how they would sit inside a LAN, a local area network design. Once we understand the concept between an access and trunk port, we can go back to the CLI and create trunks and create access ports. Now, you see me earlier talk about how we can create a VLAN when we go through at time of assignment. I said if a VLAN doesn't exist, but yet you assign it to a port, depending on the switch, it will actually create that VLAN for you. Well, when you actually assign a VLAN to a port, normally you only can assign a single VLAN to a port, and that's referred to as an access port. So a single VLAN is an access port, which must mean the opposite of single is obviously multiple, right? Which means the trunk port is where you would have multiple VLANs. Now, looking at this diagram, you can see that I have VLAN blue, VLAN red, and 4 devices, 2 in each VLAN, that connects into this particular switch. Well, each of these ports will be an access port, and each of these ports will be an access port. But there'll be an access port into different VLANs. Let's say this is VLAN red, and VLAN red has an ID of 10, which means they're in VLAN 10. This is VLAN blue, and this has an ID of VLAN 5. So the way I would do that is go into the switch, config terminal, type the word VLAN space the number or the ID, which is 5 or 10, and then when I'm inside that VLAN sub configuration mode, I can then name it blue or name it red. So we've seen how that part works. Now, same to be true over here. I would simply go into this switch and create red again, ensuring that the number matches up. I would go into this one, again, call it blue, and the number matches up. And for the orange one, we're going to give it another number, let's say 11. So that means that we've gone in, we've created our VLANs, and we've assigned each port a single VLAN, which is referred to as an access. Now, the only time that the VLAN will be singular is if it connects down to an end host, to PCs. If it connects between switches, this is where our trunks come into play. So we'll go into this port, and we'll go into this port, and instead of putting it into a access and specifying which VLAN we want it to be a part of, we would make it a trunk. And the idea here is this trunk will carry all of the VLANs back and forth. So if the PC, let's say here, sends out a ARP, a address resolution protocol, trying to find the MAC address, that would go to the all Fs. And we said that if something went to the all Fs, this would be a broadcast frame. And as such, it would go up to the switch, out only VLAN 10 ports, and it will go across the trunk port and outside any VLAN 10s on the other switch. So this trunk allows us to have multiple VLANs across a single port, as opposed of an access that only allows a single VLAN against a single port. So access ports are pretty straightforward. There's only a few commands that are really involved in doing this. First of all, we make it an access port by specifying the switch port mode is access, and we do that under the interface configuration. And then once it's a access, we then specify which VLAN it should be a part of by switch port access VLAN and whatever VLAN ID. So we can't put the name here because the name associates with the VLAN only to make it easier for us, but we do have to put the ID here. So if we've named a VLAN, let's say VLAN 10 is red, we need to make sure we put VLAN 10 here, not the word red. It just simply won't let you. To verify it, we can look at the show VLAN, just what we've done a moment ago, and we can see whether that port is part of that VLAN. Or we can look at the port directly and ensure the switch port is put on the end of the command. So show interface, whatever interface that we've selected up here, and then the word switch port. Very straightforward. So let's jump onto Cisco. Okay, so here we are on switch 3. We're going to go into, let's say, an interface. And we're going to go switch port mode access, switch port access VLAN, let's say VLAN 14, show VLAN. And then we can see the VLAN 14 called test, which we previously created, now has gig 020 inside of it. We can then do show interface gig 020 with the word switch port on the end, and it's going to give us a lot of information, most of which we've not yet talked about. However, there are a few things that's worth pointing out. First of all, we can see that the switch port is enabled. This means that it's a layer 2 port and not a layer 3 port. If we were to turn the switch port enablement to disable, we could then assign an IP directly to this interface, providing this switch actually supported that. We can see that the administrative mode is access. This means the switch port has been statically set up to be a access port. The operational mode, which shows static access, is the output based on the administrative mode. So later on when we talk about DTP, the dynamic trunking protocol, we'll know that the administrator could set something called dynamic, and the output of the dynamic may result in the port becoming a trunk or an access. Depending on the output, this is what we call the operational mode. Here, the operational mode and the administrative mode are both access, and the reason they're both access is because we've gone onto that port and hard set it to the access. We can also see some important features around the trunking. So if a trunk were to actually come on this link, what would be the preferred method of encapsulation? Is DTP running? In this case, the negotiation of DTP is turned off, and it's turned off because there's no point trying to negotiate something if we've hard set it. And because we've hard set it to an access port, what VLAN, in this case VLAN 14, and which name of the VLAN, VLAN test, has been assigned to gig 020. So there's a lot of information in this output, both to help us verify the trunk, the access, and how it became a trunk or access. So diving a little bit more into trunks, now we've actually seen what they look like and where they would sit in our topology, and kind of an overview of what they're trying to achieve. Let's dive into actually creating that trunk and having a look at some documentation. So how you would create a trunk. Now this is actually how you would statically create a trunk. You can see here you actually set the mode to a trunk, and depending on the switch make and model, it sometimes asks you which type of encapsulation you would like to use. The .1Q is a IEEE standard, which means it's an open standard, but there's also ISL, which I don't believe is on the CCNA, but it's the older Cisco proprietary solution to achieve trunking. Now, how does it actually work? You remember previously we had our two switches, and our two switches are connected with this cable, and we said that this port that connects the two switches together is a trunk port, as opposed of the downstream connections to individual PCs, which are access. Well, if VLAN, let's say VLAN 10, were to broadcast traffic across this single connection, these switches need some kind of method to know that this is actually traffic for VLAN 10. And the way they do that is they insert what's called a .1Q tag. And you can see just at the top here, this is the original Ethernet frame. We've got the destination MAC address, the source MAC address, the length or type of the actual Ethernet header, the data, and in the data field, this is where our upper layers would sit. So this is where IP, TCP, UDP, and the application. So this is the upper layers. These are our lower layers. But ultimately, they've all been encapsulated inside this frame that's been sent across the wire. But before it's sent, the switch on this port inserts the tag for the VLAN that it belongs to. So as VLAN 10 sends, for example, an ARP, before that's sent across the link to the switch, a trunk link, it's inserted here with the number 10. So when the receiving switch sees that trunk and looks at the frame that comes in and notices the 10, it's able to understand that this frame should only be sent to anyone inside VLAN 10 and not to anyone inside another VLAN. So that's our way of actually ensuring that both switches are able to identify the frames going back and forth each other and ensuring that the traffic remains in the correct VLANs. Once our VLANs have been created, we got a series of different verification commands. We can look to make sure that the trunk is actually formed, and we can query the actual interface, this interface, and ensure that the switch port configuration has actually identified itself as a trunk. Now when it comes to trunks, there are a lot more configuration than actually shown on this slide. There are protocols such as DTP, the Dynamic Trunking Protocol, which are switches used to speak to one another in order to understand whether this link should actually be a trunk or whether it should be an access. So it's a negotiation protocol. And things like VTP, the VLAN trunking protocol, has an impact on whether the trunks are formed or not. For now, on this video, we're staying very high level and we're just going to get some trunks working and having a look at it. But in the videos to come, we're going to dive deeper into things like the allowed VLANs. So which VLANs do you want to go over this trunk? Maybe, for example, we don't want VLAN 10 to go over the link between the two switches, and we only want VLAN 5 to go over the link. And we'll jump into understanding why you might want that and how you would go ahead and configure it. But for now, let's keep it simple and let's go ahead and make one of our links to another switch a trunk. Okay, so here we are. We're inside switch 3 and we're going to configure a trunk. And we're going to do that on gig 020. So first of all, let's have a look at the running config for the interface 020. So in order to configure this as a trunk, we're going to go into the interface itself. So I'm going to go into config terminal, put in the interface we'd like to go in, and you can see now that we're actually on the config interface screen. From here, we're going to do the switch port mode trunk. What this is actually saying is it's rejected my configuration to make it a trunk because it doesn't know which encapsulation method to use. Because remember, I said that there's the IEEE method, which is called the .1Q, and there's also the ISL method, which is the Cisco way of doing it, which is an older version. And because this switch supports both, we need to actually specify which encapsulation method we would like before hard setting it as a trunk. So in order to do that, we go switch port, trunk, encapsulation, and you can see that we've got the three options. We've got .1Q, ISL, and negotiate. And then negotiate is part of the DTP, the dynamic trunking protocol, which is something we'll come on to in a later video. So for now, I'm going to use the switch port encapsulation .1Q. I'm going to press up on the arrow to go back to the command I've done previously, and I'm going to make it now a trunk. And notice that that error doesn't actually appear. So if we now view the configuration of the interface, you can see it has the switch port trunk encapsulation .1Q, switch port mode trunk. Now in order to verify the trunk, we'll do show interface trunk, and it's come up and it's shown us that there is port 020. It's on the on mode, meaning it was hard set, and we did not use the DTP, the dynamic trunking protocol. It has the encapsulation method we're using, which is the open standard .1Q. It's telling us that it's actually trunking, and it's trunking what's called the native VLAN of 1. And this is something that we'll get into a little later on why native VLANs are needed and how you can use them in your designs. It tells us which VLANs are allowed on the link. So by default, all VLANs are allowed. And this is where that allowed list would come into play, where under the interface, we can actually say which VLANs we want and don't want to go across this trunk. And then only because the VLAN is actually allowed across the trunk doesn't mean it's actually being used, because the next two output, which is they're allowed and active, and more importantly, that they're actually in the forwarding state and not being pruned. This relates to something called the spanning tree protocol, which is a layer 2 loop prevention protocol. Something that we'll get into later, but ultimately, as part of a high level verification command, when it comes to your trunks, 9 out of 10 times you want to ensure that your VLAN is here inside the actual allowed state for the forwarding, and it's not being pruned. So we can see that previously we have these VLANs that we created. Well, I think it was 14 that we created together. 10 was already here, and then 169 was already here. And as I said previously, 1 is the default. So at the moment, all the VLANs that switch 3 is aware of is currently in the forwarding state and not being pruned across this particular port. So that's actually how we set up a trunk and perform some very basic verification. That's all we've got time for in this lesson. just to review what we've talked about, we first touched base on the VLAN ranges. We said that there are these VLANs that can be created from 1 up to 4094, and inside this large range there are actually two sub-ranges that we really need to understand, which are the standard and extended. And then within the end of the standard range, we've got these legacy 4 VLANs that we can't use. As I previously said, it's really important that you memorize the ranges of VLANs, both standard, extended, and the legacy. We then looked at actually how you would go in and configure the VLAN, both via part of a point of assignment where you would create it within the interface, and globally where you would specify which VLAN ID to create and then potentially name it. We had a brief conversation around the VLAN 1. We said that by default, most switches that you buy that have the VLAN's feature set, all of their ports are a part of VLAN 1 and in turn on the same broadcast domain and can communicate to one another. It's only when you start moving those ports into different VLANs do you then start to break up that broadcast domain. And then lastly, we had a high-level look at access and trunk ports and actually creating them. So we said an access is where you would see a single VLAN, and a trunk is where you would see multiple VLANs. And then we had a look at the Ethernet header or the frame, and inside that frame we were able to see the tagging that a switch actually inserts before it sends it across to another switch. I hope this has been informative. I'd like to thank you for viewing, and if it has been, please do like and subscribe.